Hi everyone, welcome to our presentation. My name is Naomi Bassett. I'm a water resource engineer, work for RV Anderson Associates Limited, which has offices in GTA, Ontario, and East Coast Canada. Today, my colleague Alex Mason and I will be presenting the City of Fredericton flood risk assessment using Icwmm software. So Alex, can you introduce yourself, please?
Yeah, thanks, Naomi. My name's Alex Mason. I'm a project engineer with RV Anderson consulting firm based out of Fredericton, New Brunswick. I have 6+ years of experience, 3 of those with RV Anderson, focus on mainly asset management and climate change studies. So thanks for having us both.
So our presentation comprises of 2 sections. I will go through project background, scope of work, approach, and methodology, and then I will hand it over to Alex, and it's going to continue the presentation on flood damage center areas, conclusions, and recommendations on flood mitigations. So starting off the project background, RV Anderson has been retained by the City of Fredericton to assess stormwater risk, culvert capacities, and develop citywide surface water inundation mapping. Basically, this project has been done in 2 phases, phase 1 and phase 2, which this presentation is mostly about phase 2. The primary objective of this project were perform gap analysis, assess the potential impacts of climate change on stormwater inundation and culvert capacity risk, assess the impacts of riverine backwater conditions on stormwater risk. So basically, City of Fredericton has been divided by St. John River into sections, north and south side, which Nashwauk River and Nashwauk Cyst stream contributing to St. John River from the north sides. The other project goals include developing watershed-based stormwater inundation mapping to show the extent of the areas potentially impacted by peak water levels, perform a culvert capacity and risk analysis to identify crossing with insufficient conveyance capacity and elevated stormwater risk, and finally providing prioritized recommendation to mitigate surface water risks. So, methodology. These steps have been taken throughout the project to perform stormwater risk analysis and finally provide mitigation strategies on flood mitigation. Every project includes assumptions and limitations, and ours where watershed limits are based on the LiDAR data and represent surface runoff. Stormwater attenuation facilities, including ponds, were not modeled. The degree of blockage in each culvert was not inspected, and it was assumed that each pipe had a full diameter open cross-section for flow. So basically, we used Icwmm software for this study. As you know, Icwmm software is capable of performing the hydrologic simulation, the hydraulic analysis of the culverts, sewers, and channels, as well as backwater calculations to estimate inundation limits and depths. So for the hydrologic analysis section, we use a CS code number for infiltration as an infiltration method and stream method as a runoff calculation, and we chose 24-hour Chicago storm distribution for simulation runs. For the accuracy of LiDAR data, the LiDAR data was processed to remove points that were not related to the existing ground, like roofs and trees. The generated digital terrain surface model was used to delineate the watershed limits, water courses, and determine the overland flow paths. Culvert inverts were also determined from channel points on the LiDAR surface cross-section taken to 5 meters upstream and downstream of each culvert. St. John River and Nashwauk River. So as I said, these rivers were modeled as boundary conditions for the tributary water courses within the city and to assess the potential river stormwater risk. The historic 2-year, 20-year, and 100-year daily flows were used to model the river water surface profiles with the peak water levels calibrated to match historic flow elevations. Cross-sections along the St. John River were developed using bathymetry provided by the Canadian Rivers Institute. And finally, cross-sections along the Nashwauk River were developed using LiDAR data. And in regards to climate change, this study considered only those effects of climate change associated with change in rainfall. The University of Western Ontario Intensity Duration Frequency Climate Change IDF-CC tool has been used to generate local IDF curves from Fredericton Meteorological Station. Out of 3 possible climate change scenarios, the highest increase in rainfall intensity for the years 2050 to 2100 was observed for the RCP 8.5 scenario. So we run our simulations. We got the results for PC-SWIM to calculate the culvert conveyance capacity. We exported out the PC-SWIM results, including peak flows. And we developed formulas and Excel spreadsheets. Culverts were given one of 3 colors, green, yellow, orange, as a capacity ratio, and are color coded on the project mapping and in the GIS database. We also considered the culvert geometry as well to kind of calculate or determine the culvert conveyance capacity. So as you can see from this table, the analysis revealed that the 113 out of 162 culverts received flows that exceed their design capacity for existing conditions. Climate change is also expected to increase the number of culverts with insufficient capacity to convey 100-year return period design flow from 113 to 132, and the number of culverts with extreme conveyance capacity concerns orange rating is expected to increase from 102 to 119 with the impacts of climate change. So in addition to culvert conveyance capacity, we calculate or we consider the headwater ratings, culvert headwater risks as well, to determine the potential roadway overtopping. The headwater ratings are based on headwater depth, embankment height, and the culvert diameter or height. Again, culverts were given the colors, each color represents the headwater ratings criteria. And if a node shown is shown on, for example, green on map, it's representing of headwater within 0.5 meter of the roadway without overtopping, and the embankment height is less than 3 meters. So as per this criteria, we got results which representing the number of culverts with low headwater risk shows a similar range with respect to the culvert numbers, and climate change impact results as the culvert capacity analysis. A significant number of culverts are at risk of headwater saturating the road base of overtopping the road surface during design magnitude storm events. Climate change is expected to increase the number of culverts from 65 to 83 that could overtop the road during design magnitude storm events. So I will hand over to Alex to continue the presentation. Good luck, Alex.
Awesome. Thanks very much, Naomi. So moving on to the flood damage centers and risk areas that we identified during reporting. These flood damage centers were areas with residential, commercial, or institutional developments that were identified to have risk of flooding based on the inundation mapping developed from the surface water model. Some instances, they also include some critical infrastructure at risk. And we identified these areas to help the city plan their risk management and develop long-term capital investments. The flood damage centers serve as examples of locations with flood events, and they could cause potential economic disruptions or public and private or damage to public and private infrastructure. So we'll move on to some of these examples. So the first being Ashley Crescent and Barton Crescent. So this area is located on Fredericton's north side. It's an area with significant apartment buildings and condominium developments located on the right end of your screen. Flood inundation limits look like they're encroaching on residential properties, as well as a long-term care home on the downstream end there. and also potentially overtopping Royal Road on that downstream end too. And this is all kind of exacerbated by the undersized culvert located on the downstream end. So it's an interesting risk area that we identified for the city. This second area, Brookside West, also a unique situation located just upstream of the previous risk area. This area kind of has some unique characteristics and vulnerabilities associated with the stormwater management ponds, excuse me. You can see delineated on the center of your screen there. So these ponds, should they not be flood proofed, and built adequately, they might not perform as designed during flood events. So we see some marginal increases from the current to future climate change scenario, and flood inundation limits are encroaching on some residential properties and roadways closer to Brookside Avenue and Terrence Avenue as well. So the next risk area is Devon Middle School, again on Fredericton's north side. Only a marginal increase when compared to the current, compared to future climate change scenario, but flood inundation limits are encroaching on many residential properties, a community center, as well as the school property there. So this area is kind of congested due to all the development, and the natural water course, is in a constricted area now, and also due to multiple flow restrictions in the storm sewer system and the upstream culvert. And important to note with the city, this area upstream will see significant development in the future. So we'll have to keep a close eye on it. Next area is Lincoln Heights, which is a very well-known source of problems for the city. It's located along Baker Brook in the Fredericton's southeast end. This area sees extensive flooding each year during spring freshets. In this area, we're seeing some moderate increases from the current to future climate change scenario, and many homes are at risk during these flood events. And this is, the contributing factor here are multiple culverts which restrict flow, especially the downstream end. But I believe the city may have recently replaced the downstream culvert crossing Vanier Highway. But a very interesting characteristics of that area. Next flood damage center is Canada Street, located in Marysville, suburb of Fredericton. This area is seeing some moderate increases due to climate change based on the flood limits. We can see there's a potential for Canada Street to overtop due to storm flows, and there's many homes that are at risk of being impacted during flood events as well. Next slide, please.
Oh, sorry.
Oh, no problem. And the final flood damage center is Highland Avenue, located on Fredericton's north end, just off of Two Nations Crossing. We're seeing some marginal increases from the current to future climate change scenario. There's a risk for flood limits to encroach onto Highland Avenue, and the biggest area of increase is over on the right side or the east side of the map, which is mostly in green space and closer to some athletic fields below that view there. So those were our summary of flood damage centers, and based on the results of the surface water model, these flood damage centers, we developed the following conclusions and recommendations. So conclusions are the following. So RVA successfully generated inundation mapping and shapefiles, as well as risk indicators based on the surface water model. These were developed to assist the city of Fredericton with risk management planning and long-term capital improvements. Based on the results, future rainfall intensities are expected to increase by approximately 25% over historic 100-year rainfall events for the 2050 to 2100 time horizon. And current number of culverts at risk of overtopping was estimated to be 65. 22 of those culverts are located on essential roadways. The future scenario estimates the number of culverts at risk of overtopping will increase from 65 to 83, as Naomi stated earlier. And additionally, the future climate scenario estimates 119 of the 162 culverts evaluated will exceed their design capacity by 25%. So based on these results and conclusions, RVA developed the following high-level recommendations. The city, firstly, the city should prioritize culverts for replacement based on the risk analysis and start with those culverts located, start with those culverts at risk of overtopping located on essential traffic routes as defined by the city. They can continue to replace undersized culverts through capital improvement programs, which I know is ongoing, and they're constantly replacing culverts each summer. The city can consider engineered wetlands or stormwater management facilities upstream to attenuate stormwater flows and reduce the impact of peak flows within downstream areas or urbanized developments. The city can also balance and manage flood levels in appropriate areas using control structures between culvert crossings to take advantage of areas with flood storage too. Continuing on, the city can disconnect downspout connections of residential homes where they do exist still, where connections are connected to storm sewer systems. So these can be disconnected to minimize system overloads, potential for basement flooding and or contamination. As well as the city can install backwater valves, which I know they've done in certain areas. Backwater valves, also known as duckbill valves or one-way valves, but they can install them in outfalls to reduce backwater effects within the sewer system and prevent localized flooding in low-lying areas. And this should be combined with pump units to convey flow from the upstream side of the valves to the river side, the downstream side, the valves during flood events when they're closed off. Additionally, the city should review their development standards for vulnerabilities associated with climate change and potentially increase their allowance on precipitation intensities to 25% due to climate change impacts. And this would be more in line with current climate models. And the city can consider constructing berms or flood barriers in low elevation areas to protect critical infrastructure and maintain traffic flow during flood events, which is a frequent occurrence in the city. The city should carefully plan appropriate policy modifications and enhance stormwater management measures in areas upstream of flood damage centers to reduce and control stormwater runoff. And that's all we had there. So I can close on that. And thank you very much for your time. And thank you to the city of Fredericton especially. And I hope you enjoyed the project as much as we did.